Hello. Uh, this video is about the toroids used in Airpal Transceiver. So today we'll be discussing about the first transformer, that is T1. So what I'll do, I'll be discussing about this Airpal kit, how it works, and I'll also be giving you information about which stage is which, so that way with the video maybe you get a better understanding, but I'll try to make it in step by step, so that it becomes easier for you to understand what stage is doing what. So let me start in a nutshell by introducing you to the various stages. I think so I had made one video earlier on, so let me start again and give you a very brief description about the working of Airpal in a nutshell. So if you look at a typical SSB transceiver, it has a balance modulator. So this T1 is a balance modulator. We have a mixer. So this T2 and T3 are the mixers. In the center we have BAT54S. These are the diodes used in the mixer. We don't use 4148. Instead of that we use BAT BAT554S. Those are SMT diodes which are pre-shouldered while you get this board. And on this also we have a single diode that is soldered on the reverse side of the PCB. This one BAT54S. This is already pre-soldered. You don't have to do anything. I know that if there is no manual you may have some difficulty in understanding, so we had kept this project for advanced users who had the knowledge of the different stages. So let me start by telling you other stages. So if we start with we'll start with Q3. Q3 is the pre-amplifier for microphone. It is a microphone amplifier, so it amplifies your microphone signal. So this is the working of Q3. We have Q1. Q1 is the audio pre-amplifier for this audio amplifier, TDA7231. So this amplifies the signal before entering into 7231. So this is a function of Q1. We have Q2. So Q2 is a audio mute circuit. Basically it mutes any audio getting into the TX while transmitting. So this is a function of Q2. This is the audio amplifier TDA7231. So I hope now you understood that the first transistor out here, which is Q3, is the mic amplifier. The microphone signal is being amplified. Q2 is your audio mute, and Q1 is the audio pre-amplifier for the main amplifier, that is TDA7231 audio amplifier. And now we come to the mixer T1. T1 is the mixer. Now if you have not wound a trifilar coil, basically it has 3 windings, 1, 2, 3. These are 3 wires which are twisted together, and 8 to 10 turns per inch. I think so you could watch some YouTube videos how to wind a trifilar coil. So when we make this coil, we have now 3 windings. That is this is the first, this is the second, this is the third. So simply what you have to do is you have to connect these 3 wires on these particular holes. So we take this point to be A, the other end is B. Now this is second wire, this is A, this is B, the ending is B. So this is the third wire, which is A, and again this is B. So we have got 3 set of wires which are twisted together, and they are shouldered here. This is A, this is B, this is A, this is B, this is A, this is B. So when you have soldered these coils, it will look something like this. It will look something like this here. It looks something like this. So I think so you have got it now. These are 3 wires twisted together, and you have to see that the coil is spread, the wire is spread on the coil. You see this? The wire has to be spread on the entire coil. You can't bunch all the wires at one place. So it should be spaced, the wire should be spaced, and this is how the twisting has been done. The twisting you can just see on YouTube, how this wire is twisted. It's a very simple method, but I think so the video will explain it to you better. Okay, now we have done with T1. So after doing T1, now let us go to the other coil. This other coil is T2 and T3. This again is the same method. This is A, this is B, this is A, this is B, this is A, this is B. A, B, A, B, A, B. So you have to take a multimeter and see which is the starting end. This is the starting, this is the ending, this is starting, this is ending, this is starting, this is ending. So you have to check the coils, the continuity of the coils, and connect them accordingly. So I think so it is very clear now. So for T2 also we have the same configuration. This is A, this is B, this is A, this is B, this is A, this is B. T2 and T3 same. This will be like this only. So basically the wires you are connecting, this will be like this: A, B, A, B, A, B. So these are twisted again, as I showed you. These are twisted wires. I hope now it is very clear to you how these wires are to be connected. So how they work and what they do, we'll take up this matter later on. So now you're clear with winding of T1, you're clear with winding of T2, you're clear of winding of T3. So this is the balanced modulator coil, these are the mixer coils. So now let's go further. The other coils we have out here. These 2 coils are RFC, L1, L2. These coils basically are 0.5 microhenry. These basically are for balancing the crystal filter to a particular impedance. These coils, I think so we have given you wounded. And still, if you have any difficulty with the calculation, there are many online calculators. You can see how much of turns this requires. We are using T30-6 for this, so you can calculate what will be the number of turns for 0.5 microhenry. But still, I think so we have already provided you with the wounded coils. So let's move further on. What do we have now? So now we have this coil out here. This is T4. T4 is 10 turns on FT37-43. This is 10 turns bifilar. So if you are wondering what is bifilar, bifilar is basically 2 coils. It is 2 coils. Like in the trifilar we had 3. This is the, sorry, I mean to say 2 windings, not 2 coils, 2 windings. So we have this. So we have 2 windings which are twisted together. We have 2 wires, A, B, A, B. Another thing is that we have to make a center point. The center point will be like, if you take this, it forms a Z. If you take this, it forms a Z. So this will be your center point, the start of A and the end of B. So this is your center point. So what do we have now? we have 1, we have 2, we have 3. We have 3 points. 1, 2 and 3. We have 3 points. So this is a bifilar winding, and now we can use this out here. So the 1 is starting, 2 is ending, 3 we have kept in the middle. We can make this 2 or this 3, we can change that also, but I have just labeled it as 1, 2 and 3. So the first one is the 1 is starting, 2 is ending, and the center I have kept at 3. Okay, so now we come out here. What do we have? Now this is the center, so this will be 3. This will be 3. So this is 3, this is 1, this is 2. 1, 2, and the center one is 3. You look carefully out here. So this is your bifilar. So this is how the bifilar is to be wound. And for bifilar also, you have to spread the turns on the whole core. On the whole core, you have to spread the turns. So now, if you ask about what this coil out here is doing, so it is basically amplifying the signal coming from the band pass filter. This is the band pass filter. It is coming from the band pass filter, and it is amplifying the signal. Okay, so this is amplifying your TX signal. And now after this we go to another bifilar coil. This also is 8 turns bifilar wound on 37-43. This is T5. So this is also same. This also coil is the same one, like this. Out here we had 10 turns, but this one requires 8 turns. So we need 8 turns out here. This was 10 turns. This is 8 turns. So we have to wind this coil like this only. Same way. So this is also the bifilar coil out here. Okay. Now this is this basically coil is used for your driving the preamplifier for the TX. Okay, so now we have the final coil. So this will basically this will pre-driver. This is the pre-driver for the final linear amplifier for your for final amplification. Now this is the final amplification coil that is used in the MOSFET, and this coil is basically used for the driver stage for the amplifier. So these transistors are the driver ones. These are the driver. So this will amplify from here and move on to the final coil for the MOSFET. FT37-43. This is also same. It is a bifilar coil, but what will we use out here? I think so. It's not given, but we use T6. We use around 5 turns. 5 turns. So we use 5 turns on 37-43 bifilar. That means 2 wires. So this is it. And what we have this coil also. This is RFC. L9 is RFC. I think so. The details for this single winding coil have been given in the manual. You can check that. Then for low pass filter, these are the low pass filter. L9 is 0.6 microhenry. Yeah. L10 0.6 microhenry. This is 20 meter low pass filter, and this is for 40 meters low pass filter 1.4 microhenry, 1.4 microhenry. So the turns have been mentioned in the manual. This is a single turn coil. It has been mentioned in the manual how many turns you have to give, or you can also consult an online calculator. So I think so I have now given you a brief idea how the coils are to be wound, and now if you have any doubt you could still ask me. So I think so I've told you about the relays or not, I'll just tell you. So this relay basically takes 12 volts and it supplies two voltages, that is 8 volts. It will give you 8 volts and 12 volts. So it gives a dual voltage on TX and RX. So this is a voltage switching relay. We have total 4 relays. So this is another relay. This relay basically changes the TX and RX position for the antenna. So this will change the RX TX position for antenna for both the bands. And for changing of 20 meters, 40 meters, this relay is used out here for band pass filter. So across, if you see, we have the pre-wound coils which we have supplied you. These are the pre-wound coils, Toco type we have supplied you. So you have to mount the 20 meter ones out here and the 40 meter ones out here. So this relay, what it does, in the default mode it is on 40 meters, and if you press the encoder it will go to 20 meters. Likewise out here also we have low pass filter for 20 meter and 40 meter. So on default condition the relay is connected to 40 meters low pass filter, and otherwise it will be connected to 20 meters low pass filter when you press the encoder. So that said, this completes the working of low pass filter and band pass filter. This is a MOSFET out here, IRF 510. How this will work is that you need to set the biasing out here. This is a 10K preset. So you have to set around 2.5 volts on the gate. This is the gate. So you have to set, you have to rotate this and set, while pressing the PTT, you have to set this at 2.5 volts, the gate supply. So this will set your biasing. But finally, when you make the transceiver, you will have to do a couple of tuning with the band pass filter and biasing to get it into final shape. That I will show you while making this by stage. I have decided to go ahead and make this stage by stage, so you all don't have any difficulty in assembling this. So even a newcomer who would like to assemble it could try his hands on. But presently what I see is that people want a complete manual. So I thought of let me start making some videos. That way I can make a couple of videos, you get a better idea how things work. And we give you a built DDS which has a BFO and VFO. So you have to connect the BFO on the VFO side and the VFO on the VFO side. So the BFO can be of 9 MHz or 10 MHz, whatever we supply you with, and the VFO will be accordingly to the sketch. So and by step I'll be letting you know how to proceed with the other things. So I think so today I have told you about the coils, how to wind them. If you have any inquiry, do let me know, and I'll be continuing with these videos. Now I'll start making this stage by stage, so you won't have any difficulty.